Okay, so now we'll move on to the next part of our matrices lesson 6.5, using inverse matrices to reverse the effect of a linear transformation. Okay, now earlier you saw that we used the transformation matrix, we multiplied with the object coordinate and we got the image coordinate. Is that correct? So now you remember in F1, we have adding matrices, subtracting, multiplying, but we don't have dividing matrices, right? We use what? The inverse matrix, you remember? So can you see what they have done here? T x1 equal x2. So if you want to get rid of the t and make x1 the subject, what do we do? If you want to make x1 the subject and remove the t from here, what's the technique that we use? Can you all remember? Yeah, we take the t inverse, right? Then basically, if you want to remove t, we multiply both sides with t inverse, and you can say I use t inverse on the left side. So that means on the other side also I should use t inverse on the left side. T inverse and t multiplies to give you the identity matrix. Do you remember this is for the P of 1? Identity matrix times x1 equals t inverse times x2. So identity matrix, when you multiply it with anyone, it is just the x1. So x1 equals t inverse times x2. Do you agree? Okay, so this is it. So basically, we are going to now, what we'll do is, now earlier they gave us the object coordinate and the transformation matrix. We multiply to get the image coordinate. So in here, basically what will happen is they'll give you the image coordinate, and what you'll have to do is you will have to find the object coordinate. So to get the object coordinate, what you'll do is you will multiply both sides with the inverse, and you can see the inverse matrix times the image coordinate gives you what? The inverse matrix multiplied by the image coordinate gives you the object coordinate. Okay, so this is what we are going to use in this exercise. Okay, shall we start? Okay, exercise 60, question number 1. So they have given you the transformation T, which transforms the objects in 3D plane to image in 3D. It's represented by matrix T. There T inverse is given to you. The pointed question vector ABC is transformed by T with pointed question vector -12, -7, -8. Find the values of ABC. So how do we do it? So I was just talking to you about this transformation matrix into object coordinate equal image coordinate. And we just showed you that you need to multiply both sides with T inverse, and you get what? Object coordinate equal inverse matrix times image coordinate. So object coordinate is ABC. Inverse matrix is already given to you, isn't it? Inverse matrix is always given. It's already given to you. And then x2 is the image coordinate -12, -7, 8. It's just a matter of multiplying, isn't it? When you multiply 2 times -12, this is a 3 by 3 matrix multiplied with 3 by 1. Thereby you get a 3 by 1. 2 into -12 plus 3 into -7 plus 3 into 8. The next coordinate -1 into -12 plus 4 multiplied by -7 plus 5 multiplied by 8. The next one, 2 multiplied by -12, 1 multiplied by -7 plus 1 multiplied by 8. Are you with me? How much is the answer? Okay, the first row is -21. Second row becomes how much? 24. Third row becomes -23. So that's your ABC value. Okay, A is -21, B is 24, E is -23. Okay, then the next one. A line L1 which passes through the origin is transformed by T to line 2. Now who is the object and image? Look at this. The object is L1 and the image is line 2. Now they have given you a vector equation of line 1. Line 1 is given. The vector equation of line 1 is given. They are asking you to get the vector equation of line 2. This is basically what we did earlier, right? The previous exercise. Okay, so now here, now the problem here is that we have the object coordinate, right? So they are asking you to find the image coordinate. Are you with me?